Hello, welcome to Engineer's Mindset. So let's say we're given this problem and we are asked to determine the moment about point A of each of the force on the beam as shown. Now, first of all, let us understand what moment is. Moment is simply the product of the line of action of force and the perpendicular distance to the point of moment. Okay, so the perpendicular distance to the point of moment. So this simply means that the line of action of the force and the point you're taking moment about must always be at 90 degrees. So I want to take moment of this force. Let's start with the first force. We have force F1. The moment of this force about point A is simply the line of action of the force. So let me I will break this beam now individually for better understanding. Let me pull this beam from point A down to the point of this force. So I will simply have something like this. Okay, this is point A, and then at this point I have the force of F1, which is 375 pounds. Okay, so I have this force, and the distance it takes this force to get to point A is simply what? 8 feet from the figure. So we simply have 8 feet. Let's call, okay, so from this point to this point is simply what? 8 feet. Alright, so this is where we're taking our moment about. That's point A. Okay, so I said moment is simply the product of the line of action of force and the distance that makes an angle of 90 degrees to the point you're taking moment about. So I want to take the moment of this force about point A. This force is pointing downwards, so it means the line of action of this force is actually coming downwards. So the outside shows the line of action of the force. Now, I want to take the moment of this force about point A. The distance about point A is simply from this point. Let us liken here to point A. So we simply have from this point to this point. Now, the line of action of the force and the distance that makes an angle of 90 degrees becomes what? The moment. Okay, so this is the distance that makes an angle of 90 degrees, simply from this point to this point, which is what given as 8 feet. So therefore, moment of F1 about point A is simply what? The force 375 multiplied by the distance it takes this force to get to point A that makes an angle of 90 degrees, and that distance is simply what? 8 feet. So multiplied by 8 feet. That implies that the moment of the first force, MF1, is simply equal. So we use MF1 to represent moment of the first force about point A. Okay, that was simply equal to 3,000 pounds feet. Okay, 3,000 pounds feet. Alright, so this is the moment of the first force. The moment of this force about point A is simply what? 3,000 pound feet. Now let's move on to the next force. Now take note, this force is actually inclined. The force is inclined, but when given the angle, so which means we have to find the angle. We are given sufficient reason to find the angle. This point is 3 meters and this height is 4 meters. So we can use this to find the angles. So let's try it out and see. Okay, so let's pull out this force now and analyze. Okay, we have this force to be inclined at an angle, and we are given this height 4 meters and then 3 meters. So you can simply call this. Okay, you have something like this. This is 4 meters and this is 3 meters. Okay, let's call that the angle of inclination theta. Okay, so we use this information now to find what the angle of inclination. That is why you see the beam in this manner. It means it's inclined. This means the adjacent side, which is 3 meters or 3 feet. This is the opposite side, which is 4 feet. So we can use that information now to determine the angle of inclination of the force. To do this now, of course, we know that tan theta, to find the angle, we know that tan theta is simply opposite, which is 4, all over adjacent, which is 3. Okay, and therefore theta itself is simply equal to tan inverse of 4 over 3. Theta is equal to tan inverse, of course, 4 over 3 gives us 1.3 3, 3. And if you take the tan inverse of 4 over 3, we will simply obtain that theta itself is equal to 53 degrees. So which means the angle here is actually what? 53 degrees. So therefore this force F2 was given as 500 pounds. So for F2 equals 500 pounds. Okay, this force is actually inclined at what? 53 degrees to the horizontal. Now, it means that this force is going to have two components. One component to the horizontal and the other component to the vertical. Because if here is 53 degrees, I can trace an imaginary line. This becomes the vertical component, okay, of the force. And resolving this force in the x-axis becomes the horizontal component of the force. So this force is inclined in two dimensions. Okay, if here is 53 degrees, of course, here is going to give us 37 degrees because angle of the quadrant is 90 degrees. So if here is 53, it means here is 37. Now, for the fact that this force is inclined, it means it's a two-dimensional force. Therefore, it will have a component on the y-axis. It will also have a component on the x-axis. Okay, horizontal axis is called the x-axis. This is x-axis, while this is called the y-axis. So I have to now resolve this force in what? In those directions. So to resolve this force in the y-axis, simply hold the tip of the arrow of the force, pull the force till it meets the vertical line. This is the y-axis, that's the vertical line. And if you do that, it passes through this angle, 37 degrees. If it passes through 37 degrees, simply multiply the force by cosine of the angle it passes through. Okay, so if I do that, hold this force and put it in this line, it will pass through this angle 37 degrees, and this force will point downwards. So therefore, the vertical component of this force becomes 500 cos 37. Okay, it becomes 500 cos 37. Also, I will also resolve this force to the x-axis. Also, hold the tip of the arrow of the force, pull the force till it meets the s line. Then, any angle it passes through, always multiply by cosine of the angle it passes through. So, if I pull this force to meet the s line, which is this horizontal line, it will go all the way from this point to this point, passing through this angle 53. Okay, therefore, I'm going to also watch the direction of the arrow. This arrow is pointing to the left. Watch the direction of the arrow. This arrow is pointing to the left. So it means that this force component in the x-axis is simply going to be, okay, it will point to the left, and the value will simply be what? The magnitude of the force, which is 500 times cosine of the angle it passes through. In this case, 53 times cos 53. So you have this. Okay, so it means now that we have two components of this force acting at that point on the beam. Two components of the force. First is 500 cos 37, and the next is 500 cos 53. So we now find the values. These two forces now is what now acts in place of this F2. So in place of the F2, we have two forces. So we are now going to take this and introduce the two forces. So let's see what we have here. So if I take this off, it means that at this point, I'm going to have two forces. One of the forces is vertical downwards, and we already have the value, and the value is simply 500 cos 37. So let's obtain what 500 cos 37 is. So 500 cos 37 is simply 395.3. So it means this force here is simply 395.3 pounds. Also, since it is inclined, we also have a horizontal component for this. The horizontal component is simply 500 cos 53. So we obtain the value of 500 cos 53. Okay, so the horizontal component simply gives us 300.9. So it means we also have a horizontal component here. We have a horizontal component here, and this horizontal component is simply 300.9 feet. So the beam becomes like this for that particular force at that point. Okay, so resolving that force, we have two components of the force. First is this 395.3, and next is 300.9 feet. Now we want to take moment of this force about point A. Like I explained earlier here, moment is simply what? The product of the distance which the line of action makes an angle of 90 degrees about the point of moment. So the line of action of the force and that distance that makes an angle of 90 degrees with the line of action, that distance is what we use to multiply with the force. If we bring that theory here now, that means this is now going to give us two moments. This particular force is going to give us two moments because we have two different forces. So therefore, we apply the law of moment. We can simply say let anti-clockwise moment, okay, let clockwise moment of F2 about A. So we can simply say let clockwise moment be positive and let anti-clockwise moment be negative. So if the force has any effect that is going clockwise direction, take it as positive. If it has a turning effect that is going to the anti-clockwise direction, take it as negative. So we start with the first force. This first force is pointing downwards. I want to take moment of this force about point A. So simply, since it points downward, it means it goes all the way from this point to get to point A, which means the direction of moment is simply this direction, which is positive to our assumption. So we say let's clockwise moment positive. This force is pointing downwards, so it moves all the way from this point down towards point A. So this is direction of force, which is what clockwise and is positive. The line of action of this force is actually coming downwards like this, because the arrow is also pointing downwards. So the line of action is coming downwards. The distance that makes an angle of 90 degrees to the point of moment is simply from point A, which is the point of moment, to the line of action. This is 90 degrees. So therefore, this distance 6 plus 8 gives us the total distance. It takes this downward force to get to point A. So therefore, the first moment, you can simply call that NF2. Let me wipe this side down. Okay, I will put down the moment of the first force, MF1, equal to, we have 3,000 pound-feet. Okay, alright. Okay, so the moment of this force now, the very first force, so call that NF2, okay, prime, or call it Y. So let's call that force MF2Y because this is vertical, that's the Y force, the force on the Y direction. So let's call it MF2Y. MF2Y is simply equal to what? Okay, the distance it takes this force to get to point A is equal to 8 plus 6, and that is what 14. So it becomes 14 times 395.3. So you simply have 395.3 multiplied by 14 feet. So MF2Y simply means moment of force 2, considering the vertical component, is now equal to 395.3 by 14. This is 14 by 14. So that gives us 5534.2 pounds-feet. Okay, pounds-feet. So this becomes the moment of the second force, considering the vertical component. Okay, so considering the horizontal component, which is this, so we'll call that F2x. So M means moment of force 2, x means what we are considering the horizontal component, which is 309 feet. Now also, the line of action of the force and the distance of moment must always be at 90 degrees. This force is moving to the left. This is the arrow sign. So which means the line of action of this force is simply what moving in this direction. Okay, you can simply call it this. Sorry, I just have to explain. Okay. The line of action, since the arrow is moving to the left, it means the line of action is moving what? In this direction, something like this. And now, we want to take moment of this force about point A, which means the distance that makes an angle of 90 degrees is simply what? This height, which is from there to this point. This is the line of action of the force, and then we'll have this height, even at 90 degrees here. Okay, so we have the height, which makes an angle of 90 degrees. So it means that this force actually takes moment about this point via this height. And this height was given as what? 0.5. So the line of action of the force and the distance it makes an angle of 90 degrees to the point of moment, which is this height. This height was given here as 0.5. And again, since this force is moving to the left, it means the direction of moment will be in this direction. Since this force is moving to the left, it goes about this direction. So which is negative, that's anti-clockwise. It moves all the way from there to the moment about this point. It's anti-clockwise. So it's actually a negative moment. And the distance between it was this height. It was given as 0.5. Okay, so the moment of that force becomes 300.9 multiplied by 0.5. So moment, please consider minus. So the moment of that force becomes, first of all, since it's anti-clockwise, it becomes negative the force 300.9 multiplied by distance. Distance now is this height, which is 0.5 multiplied by 0.5. Therefore, moment F2x is now equal to minus 300.9 by 0.5. We have minus 150.45 pounds-feet. Okay, so that becomes the moment of that second force about, okay, that's the moment of the second force about point A. Finally, we have force F3 also inclined. And I told you that if the force is inclined, we always have to resolve the force towards vertical and horizontal component. Because for it to be inclined, it means it is having what? Two components. Okay, so this is the vertical component now. This is called this Y, this is the vertical component. Horizontal component will always be what? In this direction. So call this X. Okay, now if here is 30 degrees, automatically I know here is equal to 60 degrees because 30 plus 60 makes an angle on a board that is 90 degrees. So if I want to resolve this force now to the F in the Y axis, simply hold the force, pull the force in the vertical line, it's the vertical line. If you meet the vertical line, if it passes through the angle, I said, if the force passes through the angle, multiply the force by the cosine of the angle it passes through. So if I pull this force to meet this line, it passes through this angle 30 degrees all the way from here to this point. Watch the arrow as well. The arrow points downward. So you're simply going to now have this force to be 160 cos 30 because it passes through this angle 30 degrees. So 160 cos 30 will simply give us 138.56 pounds. Okay, so in this case now, we were already given an angle of 30 degrees. So there was no need to solve. All we need to do was simply know that the angle on the quadrant is 90. So if here is 30, here is 60. Unlike the first one, that's the first other force, in this other case we had sufficient to find the angle. So we had these adjacent sides 4 and 3. So it was enough for us to find the angle since the force is inclined. Okay, so if I resolve this force now, I pull it to meet this line, the passes through this angle 30 degrees, it becomes 160 times cosine of the angle it passes through, that's 160 cos 30, that simply gives us 138.556 pounds. So this becomes this vertical force now. The vertical force now becomes 138.56 pounds. The horizontal force also, hold the first tip of the arrow, pull it till it meets this horizontal line. Now watch the angle it passes through. It moves all the way from this point to this point, which means it covers this angle 60 degrees. And again, watch the direction of the arrow, it points to the right. And since it passes through this angle 60 degrees, simply multiply this force by cosine of the angle it passes through. That gives you what? It gives you the value of the horizontal component of the force. So if I pull this force now and pull it to meet this line, it goes all the way from this point to this point, passing through 60 degrees. So I'll simply have 160 cos 60. Okay, the force here will be 160 cos 60. Okay, cos 60. And that will simply give me 80 pounds. So it means that this horizontal force now is simply worth 80 pounds. Okay, so the horizontal component of the force is 80 pounds, while the vertical component of the force is simply 138.56 pounds. Now, I want to take moment of this force about point A. I will start with the vertical component. This is force F3. So let's call that moment. Let's start with vertical force now. moment F3, 1 simply means moment of force F3 in the y direction. We still maintain our rule. Clockwise motion should be positive, anti-clockwise motion should be negative. That's our rule. Now, this force is acting downward. Obviously, the line of action of the force is downward because it's acting downward. It means the line of action continues downward. The distance that makes an angle of 90 degrees to the line of action is simply from point A, which is the point of moment, to this point. It's simply, you can trace this line there. This is 90 degrees because this can also show the line of action of the force. This is 90 degrees. It means total distance from point B. Remember, here was given as point B. So from point B down to point A. That distance is equal to 5 plus 6 plus 8, which is around 19 feet. Okay, so which is 19 feet. That's total distance to take this force now to get to point A is 19 feet. Also, since the force is pointing downwards, it means it goes in this direction. It's going to turn about this point, which is this direction. And it's positive, that's clockwise. So it means the moment of this force is actually positive. Okay, and the value becomes what? Force times the distance it takes to get to point A. And that distance is simply what? Given as 15, that's at 19. Sum of 5, 6, and 8 is simply what? 19. Okay, so therefore the moment of that force becomes 138.56 multiplied by 19 feet. Okay, and that will simply say moment F3y is now equal to 2632.64 pounds-feet. Okay, so that becomes the moment of that first force. Okay, next find the moment of the horizontal force about that point. Alright. Let's do the last one now. Next is to find the moment of this force about point A. Okay, this force is moving on the right. I want to take moment of this force about point A. Okay, like I said, moment is line of action times perpendicular distance. So the line of action is simply what? It runs downward from the right or to the left, simply take it downwards to this point, but take moment about point A. So this is line of action of the force. And we are with an angle of 90 degrees, still remains for this height. This is 90 degrees. So it is still this height that makes an angle of 90 degrees about point A. And that height is given as what? 0.5. Okay, so and as this force is pointing to the left, moment of this force about point A is simply going to be what? Negative, because it's going to turn anti-clockwise. It will turn anti-clockwise about point A. So the moment is going to be negative. It will turn anti-clockwise about point A. And the distance it takes to get to point A is simply what? This height that is given here at 0.5 feet. Because this is the line of action of the force. Distance that makes an angle of 90 degrees to the line of action is simply what? This height, which is 0.5. So that the moment of that force, M, F, A, X, is now equal to simply what? The force, which is 80 pounds. Now, the horizontal component of the force gave us 80 pounds. So you have 80 multiplied by the distance, in this case now, which is the height, 0.5 feet, multiplied by 0.5. And that moment is simply equal to 40 pounds. Alright guys, so that is how you find the moment of those two forces about point A. Okay, the first one was easy, it was just direct to point A, so simply the force times distance is for to point A. But the other two forces were inclined. Since they are inclined, there was a need to resolve them to what? Vertical component and horizontal component, because whenever a force is inclined, it always has two components, one vertical and one horizontal. Same thing applies there, and then you apply the principle of movement. I hope you enjoyed that video. I will see you in the next video with more amazing questions on how to find moment of forces on the beam. Thank you. In the meantime, if you're new to the channel, please don't forget to subscribe, share the channel to your friends, and of course, I would like to hear your thoughts in the comment section. Thank you. I'll see you in the next video.